You might not know this, but you have eyes. I know, it's crazy. But when you really think about it, without our vision, the human existence would have died a long time ago. Because with our vision, we can analyze and react to a ton of different things in milliseconds. For the longest time, we were the only ones that knew that this was a cup and that this is a ball. Well, not anymore. This is YOLO.
YOLO? As in, you only live once?
Actually, it's YOLO as in you only look once. You see, YOLO is an algorithm that is used in the field of computer vision. Computer vision is when you give computers, well, vision. Pretty self-explanatory.
Oh, cool. So all I have to do is strap a camera to my computer.
Not exactly. You see, computers don't see the same way as we do. As humans, we see a bunch of different shapes and edges that we piece together to make up an image. Computers, on the other hand, only see an array of numbers.
Oh, okay. But if our brains are so powerful, why can't we just find a way to replicate our brain into computers so that they can see just like us?
Well, as crazy as that sounds, that's pretty much how they did it. Introducing neural networks. Neural networks are artificial networks inspired by the human brain, consisting of tons of different layers and interconnected neurons. This is what allows computers to teach themselves to learn and recognize different complex patterns when given a specific task.
Okay. So YOLO uses neural networks.
Not just any neural network. YOLO uses a convolutional neural network. YOLO uses this type of neural network because of its ability to preserve the spatial relationship between pixels. They do this by learning tons of image features using small square inputs of data. This means that even if you squeeze or rotate an image, the CNN will still be able to recognize it.
Wow, that's so cool. But I still don't understand. How do CNNs do this?
They do this by using a special type of layer called a convolutional layer, which extracts features of an image. The first few layers recognize the low-level features of an image, such as the edges and corners. As the image goes through more and more layers, these features start to become more and more complex.
So the convolutional layers act like eyes for YOLO?
Yeah, exactly.
So then what's the brain?
Well, the brain to YOLO comes in its dense layers. These are what takes in features from the convolutional layers to process that for information, which it then would go out to locate and detect the objects in an image.
This all seems really complex. I can't imagine how many CNNs YOLO would need to use.
Well, the crazy part is, YOLO only uses one convolutional neural network, which is then simultaneously predicts multiple different bounding boxes and classes for those boxes.
Wait. Bounding boxes?
Ah, yes. When YOLO is running, it creates an S by S grid to locate different objects. Then it creates bounding boxes around objects within each grid. These bounding boxes surround potential objects in an image so that YOLO can further predict them.
So how does YOLO know if the bounding box is surrounding the correct object?
Well, the machine calculates these bounding boxes by using something called the intersection over union. This is where YOLO determines whether the predicted bounding box matches with the ground truth bounding box around an object.
So then how do you calculate this IOU?
This is calculated by dividing the area of overlap with the area of union, which then gives an IOU score from 0 to 1.
Hold up. The area of what now?
The area of overlap is when the predicted bounding box overlaps the actual bounding box. And the area of union is the total area of both bounding boxes.
So this is how the bounding boxes surround the actual object. But wait, I have a question.
Yeah?
In this image, there are tons of different objects that YOLO could detect. So how does it know to only detect these ones?
This is because YOLO goes through a process of measuring the confidence score. When YOLO divides an image into an S by S grid, it also creates a bunch of bounding boxes all over the image, some of which don't even have any objects inside of them.
But then how does YOLO know which bounding boxes to keep after that?
Well, when YOLO decides which objects are more important, it creates a confidence score with predicted classes for each bounding box. This means that bounding boxes with higher confidence scores are kept, and the ones with lower confidence scores get taken out, which then gives you your output image.
Okay, cool. So basically, YOLO first creates an S by S grid, then creates bounding boxes for potential objects, and then takes out any bounding boxes depending on the confidence score of each? Huh. With all of this, it must take a pretty long time for YOLO to give an output.
Well, actually, YOLO only needs to look once. This means that YOLO can perform object detection in real time, processing up to 155 frames per second.
155 frames per second? That's way faster than my computer.
Yeah, since YOLO can perform in real time and is really fast, there are a ton of different applications for it. One being in self-driving cars.
Oh yeah, because YOLO can run real time, which means that it can detect people, other cars, lanes, different signs, and a ton of other things when using self-driving cars.
Exactly. But YOLO isn't just meant for self-driving cars. There are a ton of other applications, such as facial recognition, crime detection, or even social distancing detection.
Well, even though YOLO is super powerful and has all these kinds of applications, there's still one thing I'm scared about. Object detection is only going to get better and better. It's going to get to the point where it surpasses our human vision. Shouldn't we be afraid?